Vibe coding is easy. In just a few minutes, you can have a really great looking and completely functional demo up and running. Honestly, even training AI models and configuring AI agents can be done relatively quickly these days.
However, as a tech PM, you absolutely must ensure that your AI functionality is anchored to actual business impact. You need to think like a business owner, right? You have to define the real business value right along with the expected costs and benefits of a solution.
So, imagine you're working at a music streaming startup that currently has 100,000 paying customers. Awesome, right? But your startup experiences a 40% annual customer churn rate. That means 40,000 customers cancel every single year. Yikes. Management has given you a top-down opportunity to reduce this annual churn to under 15%. Your goal is to detect and prevent 25,000 customers from churning annually, and you have to do it in a cost-effective way. To solve this, you and your data scientist decide to build a binary classification model to predict whether a customer will churn or not. But, well, there's a problem.
How will you and your data scientist actually know if the churn prediction model is good enough for production? Well, one way is to establish model evaluation metrics that measure the financial cost of incorrect predictions. Think about it. If your model falsely predicts a customer will churn, that's a false positive. Let's say the cost of a false positive is just a one-time $5 discount sent to a customer who didn't actually need it. Not too bad. But if your model incorrectly predicts a customer will not churn, that's a false negative. The cost of a false negative is much, much higher. It's the lost customer lifetime value of $299.70 per customer, based on a 30-month lifetime at $9.99 a month. Because false negatives are just far more expensive than false positives, your model absolutely must emphasize the recall metric to reduce those false negatives.
Okay, so to define a specific recall goal, you run multiple simulations, kind of like a model prototype, adjusting a prediction threshold from 0 to 1. Now, looking at the simulation table across 11 different scenarios, the lowest misclassification cost is $260,836, and that happens at a threshold of 0.2. This lowest cost outcome allows you to derive a strict recall goal of 0.99. Now remember, this is a goal, so it remains to be seen how closely the actual churn prediction model created by your data scientist can reach it. But a simulation result table like this can totally be used to make trade-offs with actual recall results. And as the simulation chart shows, at this 0.99 recall goal, the model is estimated to find 39,675 churning customers. This estimate easily surpasses the business goal of detecting and preventing 25,000 churning customers. Furthermore, armed with this really solid data, you can justify to management that $260,836 is a highly cost-effective solution compared to, well, doing nothing, and losing an estimated $11 million in customer lifetime value. So, by running simulations and calculating costs, such as misclassification costs, you successfully bridge the gap between AI model evaluation metrics and actual business value.